Hello everyone, welcome back to the channel. In today's video, we are going to understanding one of the most important topic in mathematics, functions. First, we will learn the definition of functions in a simplest way. Then we will clearly understand the different type of functions like one function, many one function, onto function, and bijective function. This topic is very important for class 12th. So watch the video till the end and you will understanding functions in a very easy and clear way. Let's begin. First function. Let x and y be the two non-empty sets. A function or mapping f from x into y is written as f from x to y is a rule by which each element x in the set x is associated to a unique element y in the set y. It means that each element, otherwise every element x in the set x is associated with the unique element y in the set y. Then f is said to be a function from x to y. Look at the function here, this function. Every element in set A associated with the unique element in set B. A is associated with the 1, B is associated with the 2, C is associated with the 3. Therefore, this is called as an function. But look at here. Every element of set A is associated with the set B, but it is not unique. B is associated with the 2 and 3. Therefore, this function is not a function from set A to B. Okay, understood what is a function, what is not a function? Example. Next, we will go to the next concept is that the element of x are called domain of f. Previously, we saw that the element of x are called domain of f and element of y are called codomain of f. Set x is domain, set y is codomain. Then images of element of x is called range of x, which is subset of y. It means that in this, what is the image of A? 1. Image of B? 2. Image of C? 3. Then set which contain the 1, 2, 3 is called a range, which is a subset of set B, otherwise codomain. Understood? Now that is only the image of element of x is called range of x, which is subset of codomain or y. Then every function is a relation, but every relation is not a function. Okay, previously we saw that this is a function, but it is not a function, but it is a relation. Okay, it is not a function. Then we will come to the next concept, types of function. First one is one function, also called as an injective function. What is an injective function? A function f from x to y is said to be one function if image of distinct element of x under f are distinct. It means that every element of x has a distinct image in y. Look at here. First one, what is that? 1 contain the image A, 2 contain image B, 3 as an image D, 4 as an image C. It means that every element in the domain has distinct image in the codomain. Okay, na? Then this is called as a 1 1 function. But look at the 2. 1 has an image B, 2 also image B. It means that the 1 and 2 contain the same image. It is not a distinct image. Therefore, it is not a 1 1 function, but this is called as an many one function. Understood? Then once again I am revising the 1 1. A function f from x to y is said to be 1 1 function if image of distinct element of x under f are distinct. How mathematically we can prove the 1 1 function? We will take as an two element whose images are equal. If images are equal means we have to prove that their pre-images also must equal. Then we can say that the function is 1 1. It should be satisfied for the all the element of an codomain, sorry, domain. I will take as two element in the domain x1 and x2 in the x set x such a way that their images are equal. We have to prove that their pre-images also equal. Then a function which is not a 1 1 is known as a many one function. Already I told that in this is a 1 1 function. This is not a 1 1 function, but it is a many one function. Next, onto function, otherwise surjective function. A function f from x to y is said to be onto function or surjective function if every element of y, every element of codomain is image of some element of set x under f. It means that every element of codomain must be image for some element in the domain. Okay, na? For every y in the where in the codomain there exists an element, at least one element x in the set x such that f of x is equal to y. Look at here, every element b and b1 and b2 in the set b, these are the all the element or the image for some element. It may be 1, it may be 2, it may be 3. b1 is the image for a1 also, a2 also. b2 is the image for a3. It means that every element of set b is an image for some element of an a. Therefore this is called onto function. Okay, then be careful how to prove in the mathematical way. For every element of y in the set y there exists an element x in the set x such that f of x is equal to y. This is a mathematical way to prove that onto function. Okay, in other words, a function is called onto function if its range is equal to the codomain, because we told that all the element of an y must be image for some element. It means that range is equal to the range of x is equal to the codomain. Okay, na? That is also enough to prove that it is an onto function. Okay, next, bijective function, otherwise 1 1 and onto function. A function f from x to y is said to be bijective function if it is both 1 1 and onto. If it is a both 1 1 and onto, then it is called as an bijective function. Okay, next, composition of functions, composition of two or three functions. Let f from x to y and one more function g from y to z be two functions. Then composition of function f and g is a function from x to z, from x to Z and denoted by F composite G and given by F composite G of X is equal to F of G of X for all X belongs to set X. Be careful. What is a composite function? I will take a two functions, F from X to Y and G from Y to Z. Be two function. Then composition of a function F and G is also a function that is from where to where? X to Z and denoted by F composite G and given by F of G of X is equal to F of G of X for all X belongs to domain X. Okay, be careful. There is a four note here. In general, F composite G of X is not equal to G composite of F of X. Okay, one thing. In general, G composite F is 1 1. It implies that F is 1 1. Composite function is 1 1. G composite F is 1 1 means F is 1 1. Same way, G composite F is onto, it implies G is onto. Here F is 1 1, here G is onto. Be careful. Okay, now this is one of the rule to help you to prove it directly in the MCQ. Next, third point is that if F X to Y and G from Y to Z and H from Z to S are the function, then F composite of G composite F is an H composite of G of F. Okay, next, one of the important, in this case you will get a 5 marks question, invertible function. Okay, a function F X to Y is said to be invertible. There exists a inverse means if there exists a function G from Y to X, reverse of this one, such that G composite of F is equal to Ix and F composite G is equal to Iy. Okay, this is only the definition. How to prove the invertible? We will say the some another method. But what is an invertible function? A function F from X to Y is said to be invertible. There exists a one function G in such a way that it is defined from Y to X such that G composite F is equal to I of X and F composite G is equal to Iy. Be careful, the function G is called inverse of a function F and is denoted by F inverse. To say that function is an invertible, to prove the function is invertible, one should prove that it both 1 1 and onto. This is one of the easiest way to show that it is an invertible. Just prove that it is a 1 1 and onto. Then it is a bijective. Every bijective function is an invertible. Okay, now this is a proof to prove that inverse of a function. Then the second point is that if F is a function from X to Y and G is a function from Y to Z are two invertible function. Both are, F is an invertible and also G is an invertible. Then G composite F is also a invertible function with G of F whole inverse is equal to F inverse of G inverse. Okay, then this is an about the functions. In the next video we are going to learn the different example on the invertible functions. That is a very important for the 5 marks question. Okay, thank you so much. Bye, take care.